Yeah, so we've talked a lot this morning about edge services and trying to use prpl as a platform to actually enable these. And what I'm going to go through for the next 15 minutes is just how we've done this and how we are actually taking advantage of the technologies that prpl has developed to enable this. So I'm just going to give some background around the different types of edge services that we expect to operate on these platforms, and then how the traditional model has worked, and how we want to look at evolving this into new application deployment strategies. So right now, we've talked a lot about edge services. The primary one we see today is a speed test. A lot of people want to embed that into their router. And the speed test has a corresponding application in the cloud. So it's very important when that speed test gets updated, because the application cloud might get updated, that the speed test gets updated at the same time. Right? So in a lot of cases, we do this tight integration of an application. And whenever anything changes in the application cloud, we end up having to redo the application in the embedded platform. And then we go through the usual 6-month effort of testing it and deploying it and handing it over to the service provider. So before we know it, one small change takes 6 or 8 months to get into the hands of the subscriber. So speed test is just one application. We're talking about endless number of different applications. Some of these are already integrated today, but a lot more are going to be integrated in the future. And we can't really afford to constantly do this 6-month implementation, test, deploy cycle. It's just going to kill lots of different companies. Not only is it a problem for an individual application, for an operator, they operate across different markets with different manufacturers on different access technologies. And the problem here is that your one speed test application runs on one platform, but suddenly you have to push it over on 7 or 8 different platforms. And you have to get that all aligned with your marketing department to release at the same time. So it's very, very difficult to coordinate that. And obviously with different manufacturers, they've got different priorities, and that all kind of leads to a lot of confusion and impacts the actual deployment strategy. So just think of one application. It has to run across all these different platforms in the operator footprint. So yeah, we've spoken earlier about RDK and prpl and the differences in the need for both of them to be there. At the end of the day, both of these platforms are primarily home networking stacks, right? We spend a lot of time fixing the DHCP issues, as we mentioned earlier. We need to move on from the kind of Me Too stuff. We need to look at how we put extra services on top of these platforms and what are the key enablers to put those into these 2 different stacks. So there's plenty of scope to add extra services in these platforms. Most of the gateways that we sell today, they have 20,000 DMIPS. They have no CPU problems. Some of the challenges might be around the RAM and the flash storage, right? But we'll talk a small bit about sustainability later, and how the RAM and flash is a big part of that story, and how we kind of evolve to keep these products going by making sure there's sufficient capacity in there. So just going to an example of an edge service integration, a lot of people here will understand this model. So we have 2 different vendors making the same hardware for the same operator, and they're expected to put edge service X onto their platform. So obviously, there's a lot of impacts here when we're adding in that service, right? So there's application software, different libraries are required, extra drivers, a whole host of different changes that can happen to a platform. So these app integrations can be different. So when you end up deploying it, you might get different behaviors. So we want to rule that out as well. So traditionally, we have this model, this waterfall development model, where we provide all of these fixes, we deploy it after about 6 months of effort, and then we hand it over to an operator, right? That takes quite a bit of time. But we introduced it agile development. So agile seemingly solves everybody's problems. But the problem here is that if we do a 2 or 4 week deployment, we now need to give it to an operator. They need to test it and deploy it, and then they keep repeating that every month or every 2 months. So even though we've solved the idea of getting something quickly into the field, we haven't gotten away from the effort that's involved. So we're still stuck with a lot of effort, even if we go to an agile model. So these are some of the limitations of the current model. There's time to market. So if you've got 2 or 3 vendors, how do you guarantee they will all deliver at the same time and meet your delivery dates? There's a huge testing overhead, both for the vendors and the service providers. And obviously, working between the different vendors is a challenge, right? Making sure they all deliver. And then a big part of this is, there are some companies here who want to get involved with Purple OS and build their own development teams, but that shouldn't be the case for everybody. You shouldn't have to become part of the overall development process. You should be able to take Purple OS and then use other applications on top of it without having to spend lots of money employing developers. So a bit like if we were supplying Microsoft Windows, we don't need to have Microsoft Windows engineers just to use the latest application, right? We need to move away from this idea of always becoming involved in the development cycle. So some of the ways of solving this would be to enable containers in the platform, use a standard Linux APIs, as was mentioned by Soft at Home a minute ago, and standard middleware APIs, right? So this is within the system. So obviously we can program to Linux standard APIs, but within the system, there's a lot of managers that we need to interact with. So we need to use standard APIs for that. And when you're running software from potentially third parties, you need to be able to control the resources those containers have. So we need to have that proper, secure, resource-constrained container option. And then in terms of deployment options, we can begin with embedded containers, which means we don't need to have that USP orchestration layer at the back. It can be part of our overall deployment strategy on a monolithic firmware image. But then we can evolve over time to orchestration. So everybody can recognize this, right? We have native apps today in existing platforms. We could do virtual machines, but they're just far too heavy for embedded platforms. So we've steered away from that. So we're just doing containers right now. And we're building into our platform on Purple the idea of container support along with LXC, C-run, and potentially in the future C-run for OCI. So with I suppose the key enablers for Purple as we see today, and this is what's been delivered both within the Purple community as well as RDK, is this whole idea of container management, container storage, the use of standard Linux environment for containers, and then the addition of a Purple high-level API to let applications interact with the service. Once these things are in place, we then can create the execution environment that allows the applications to operate in their little sandboxes. So those applications can talk to the runtime libraries, they can talk through the Purple high-level APIs, or they can talk to their application cloud. It's all done on an organized basis. But we're using LCM to create this environment and operate the environment. And then on top of that, we bring in container orchestration. So we're moving away from just, say, rolling out an image with an embedded container in there to being able to download containers directly to the platform. So this is the embedded option, right, as I just said. So what we're trying to do here is, or what we're suggesting to do here is that the box with the yellow sections is the monolithic image that we say is release 1. And what we're able to do is deploy release 1 repeatedly, but we add on the container, which is a separate block of code, which has nothing to do with the rest of the image. So this helps us. We don't need to go through 3 months of acceptance testing on the big left-hand block. We can only focus on the right-hand small block. So this really helps time to market. And if we need to add a new application, or if we need to update that application, we can just change that application itself. We don't need to go through the 3 months development on the main monolithic image. But obviously, orchestration is a lot better to be using, right? So I'll just flick through all of this. So the idea here is we get our existing firmware, the one that we've decided is our monolithic image that has container support and everything we need. And rather than focus on redeveloping that all the time, we develop on the different applications individually. We can push them to a repo, and then from there, using our container orchestration solution, push those down into the platform, right? And now we have full control over what applications are getting into the execution environment on the platform. We can choose to put them into RAM, we can choose to put them into Flash, we can choose to do download on demand. There is a lot of flexibility with that orchestration idea that we wouldn't necessarily have otherwise. So this is the orchestration overall system, and this is where potentially we're able to introduce the OEM software, additional operator software, but also these third-party software elements. So we're building an ecosystem to allow third parties to develop in the platform. In theory, they could do that independent of the operator, right? If we are serious about creating an application environment, we need to give those third-party software developers all the tools they need to be able to do that, right? Operators are not going to invent every app that they're going to use. They're going to have to depend on third parties to do this. And third parties will only get involved with us if we provide the necessary tools to let that happen. And they don't really want to spend 6 months with us as vendors or with you as service providers implementing this software. They would much prefer just to take their container, tidy it up, adapt it to whatever interfaces we have, and push it into the repo for immediate use. Okay, that's just that. So just a small product placement here. So we, in CommScope, have developed our own orchestration platforms called Home Assure Fleet, and it's standards-based. It's supporting the full container orchestration that we need for LCM. It does full CV lifecycle management, and does pretty much everything that you need for a containerized solution, and manage it across hundreds of thousands, if not millions of devices. And we do have a demonstration of that just over in the corner that you'll be able to see at your leisure. This is a screenshot of what we're doing. So what we've done, obviously we've talked a lot about what we could do, but what we've done at CommScope is we've taken the prpl LCM components and we've implemented them on a next generation hardware platform running prpl, but we've also managed to run it on RDK. So at NetworkX, we've had a demonstration with 2 different platforms based on the same hardware, running 2 different operating systems, but using prpl LCM. And we managed, in this case, there's a handful of applications there. They're all independent applications. We can use them on either of the platforms. We download them and run them. And the orchestration system, if you want to see how it works, we can just install or remove the devices, the software components. It's an amazing system in terms of LCM, what it's able to do. One of the key things to bring your attention to is we spent several months developing this solution. We have several applications at the bottom, so that would be Final Fate, Demotics, and Speed Test. So there was a lot of effort put in to make sure they worked. But we got the prpl web UI on Sunday night. We spent probably 5 minutes adding it into the repo, and we were able to use it straight out of the box. We didn't touch anything on the platform. So we were able to run a brand new user interface on top of our LCM solution, on top of the prpl platform. So just in summary, the whole idea of containerization is going to bring this whole new scalable model required for deploying edge services. So it allows everybody to come into the mix, the OEMs, the third parties, and the service providers. It hugely improves delivery time across these different platforms, particularly if you've got an operator spanning multiple countries with multiple manufacturers. The LCM gives us a containerization option for the main gateway stack. But what we've seen already is that it's not just for prpl. We're able to run it on RDKB as well. So we're giving everybody the opportunity to use this. There's different ways of deploying containers, either embedded or through the orchestration. And this whole system is based around open standards. So this is all based around broadband forum standards, TR157, USP, TR181. So it really is a very interesting option right now to help support that deployment. And just in terms of, just one other point about this, so there was a small discussion about sustainability with platforms. So obviously everybody wants to talk about plastics, recycled plastics and everything else, and low energy. But one of the things that we see is if we have an old gateway in the field, right, if that's 3 or 4 or 5 years old, and a service provider comes back to a vendor and says, I need a new feature added in there, it's very, very difficult to justify that development, right, on a 5-year-old product, right? But if we have a containerization environment, it's much easier to actually say, well, here's a new application. You've got a containerized environment. Just take that application and deploy it. So now, rather than saying, well, it's a 4-year product or it's a 5-year product and it's reached its end of life, Now we can say, well, containers, yeah, we can download 2 or 3 new images. We can extend it for another 2 or 3 years, right? So that really is a big sustainability enabler, right, to keep it in the field. You know, we need to make sure we're not just pulling those boxes out and replacing them with new ones. That's not sustainable. So, okay, so this is just a pointer for over there. I think this was for Network X, so it's a different one, but it's just over there in the corner if people want to have a look at it. We'll take you through that. So, thank you.